Welcome everybody to this webinar. I appreciate your taking your time and effort to view what is happening at the Peers Data Hub. My name is Katherine Baisden. I am the data manager of the Peers, which is the Partnership for Expanding Educational Research in STEM Data Hub at the Inter-University Consortium Consortium for Political and Social Research, ICPSR. The Peers Data Hub is funded by the National Science Foundation and is collaborative with the American Educational Research Association and ICPSR. The Peers Data Hub features ways to explore and discover data sets for secondary research and analysis, avenues for connecting with colleagues and like-minded researchers, and resources for data and research management. If you would like more information about Peers, please visit us at www.peersdatahub.net. One of the things is that collecting data is an expensive proposition, so we are trying to provide access to secondary data sets, which is very practical, less expensive, and there's a lot of rich data out there. The agenda for today, we're going to cover Let's Date the Data, public versus restricted data. Where do I go look for educational data? We will look at the National Center for Educational Statistics, NCES, looking at using their data lab online tools and how to download data from NCES. We'll also look at the National Center for Science and Engineering Statistics. Again, we're going to look how you can download data sets from them and use online tools. And we'll have a brief introduction of ICPSR and a Q&A session. Where do I begin? It's all so confusing. So much information. Let me tell you, I'm taking this journey along with you. I'm fairly new to these websites, fairly new to this position. So I wanted to take a journey to see what I would want to know if I was looking for data. I'm going to call and say, let's date. I truly believe that before you decide to do extensive analysis on a data set and get involved in complex issues, that you need to take a data set or data sets out for a spin. You need to date. And when you're dating, the kinds of things that you really want to ask are, what type of data are you working with? Cross-sectional, longitudinal, cohort, panel. You want to understand the sampling frame of the data. Is it a simple random sample? Is it a complex sampling design, which is very common in educational data? You want to become familiar with the code book or the data dictionary. You want to become familiar with the questionnaire itself and how skip patterns or filters are handled. You don't want to look at something and say, oh my gosh, half of my respondents dropped out. Oh, that's because that question is only for a certain gender. Select your variables based on your conceptual framework. Run frequencies on those selected variables to see if you have outliers, response categories that don't match the instrument question. Perhaps the question has 5 response categories and now you're looking at 7. What happened? Understand the type of variable you have, whether it's a numeric variable, a character variable, categorical variable, and how does that fit in your analysis? Understand the coding assignments of missing values, not applicable answers, or do not know responses. After all this, after dating your data, are you ready to propose? We are going to be focusing on public use files today. Public use files are generated from surveys, administrative data, or a mixture of both, and they're suitable for use by the public. They have been curated to protect the confidentiality of survey respondents and by removing or recoding individually identifiable information. But I do want to talk briefly about restricted files because sometimes public use files just don't meet our needs. We want to go a little bit deeper. But restricted files, first let's define them. They contain detailed information that the public files have, and they also include sensitive or confidential information that could identify individuals. Restricted files are protected by laws and requires special protections to prevent unauthorized access. And access to these files usually requires users to apply for and be granted a license to access the data. There are three types of identifiers that are associated with restricted files. Direct identifiers, the ones that we really know, like your name, your social security number, your telephone, those ones that you're really afraid that you're going to have identity theft with. Then you have sensitive information, reports of criminal history, mental health, sexual behavior, drug use, HIV status. And then the third category is indirect identifiers, detailed geographic information, organizations, educational institutions, occupations, income, office held. And that's where things get a little bit murky, a little bit harder to figure out. But for example, if you have the following set of indirect identifiers, age range 55 to 65, gender male, location central neighborhood, occupation retired farmer, someone could put those factors together. And like in a small town with a limited number of older male farmers residing in a central neighborhood, this actually putting these factors together could actually point to a single individual. Yes, restricted data gives you more information about your subjects, but more information also means more responsibility on your part as a researcher. Anytime a respondent fills out a survey or participates in a clinical trial, they are entrusting you with their personal information, a great responsibility. If the public can't trust researchers with such information, we endanger the viability of future research. We won't focus on restricted files today, but I wanted to let you know you get a little bit more bang for your buck, but at the same time, you have to deal with the responsibility of that. There are 13 federal statistical agencies, and they range from the Census Bureau down to transportation statistics, as you see listed here on the slide. The two agencies that we are going to focus on today are the Institute of Educational Sciences, which actually houses two subunits, the National Center for Education Statistics, the National Center for Educational Research, the National Center for Educational Evaluation, and the National Center for Special Ed Research. And the other unit we're going to focus on today is the National Center for Science and Engineering Statistics, NCSES. I'll just give you a little bit of organizational chart for the IES. The IES has these four branches. The National Center for Education Research supports rigorous research that contributes to the solution of significant educational problems in our country by funding predoctoral and postdoctoral research training programs and other research activities. The National Center for Education Evaluation, NCEE, focuses on conducting rigorous impact studies on promising education programs and practices that are supported with federal funds. The National Center for Special Education Research supports rigorous research on infants, toddlers, children, and youth who are at risk for disabilities or have disabilities through advancing the understanding of the practices for teaching, learning, and organizing educational systems. The unit that we will talk about today is the National Center for Education Statistics, which is a primary statistical agency for the Department of Education. It focuses on the collection, the processing, and the analysis of information for statistical purposes. And this is where you have an idea, you want to go out, but where do I begin? Let's start with the National Center for Education Statistics. These are some data sets available in CES for analysis through their online tools, Data Lab and PowerStats. These are just a sample of some of the most popular data sets that are used. There are over 98 data sets that deal with primary education, secondary education, and post-secondary education. As you can see, some of these are marked with a double asterisk. What that means is that the ICPSR archive system actually actually has them available. I would say you can point to them, but when you point to them, the data is not housed here at ICPSR. But if you pick one of these data sets, what it will do, it will pop up and tell you that, oh, we don't house the data, but here, let's go to this website. The ones that have the plus signs are data sets that are available at ICPSR, but they probably are earlier versions of these data sets. Many of these data sets are longitudinal in nature or panel in nature, so you have various time frames that you can pick from. ICPSR may house some of the earlier versions of it. And so if you're interested in the earlier versions, that is one way that you can have access to these public use data sets. If you're interested in the current versions, you may have to go to other websites. The National Center for Education and Statistics requires that you create an account before you start exploring their website and the options and possibilities there. This is a very traditional kind of put your email address in, tell them you're not a robot. They send you an email, and in that email, there's instructions on creating a password. And then once you have done that, you have an account with NCES. They will require you to sign into that account anytime you're using their tools. This slide is a screenshot of the NCES Data Lab homepage. Now, you'll hear the words Data Lab and you'll hear the words Power Stats. The Power Stats is the actual software that computes the analysis that you want, but it's associated with the Data Lab. So what I want to point out here is some of the characteristics of what we're looking at here. Number one here is the navigation tray. You'll see this gray strip, and in there you'll have icons for home, tables library, power stats, online code book, information about the data lab, a learning center, and down here a help desk. 2 is where you log in, over in this area here. 3 is an area they give you updates. Anytime they're releasing new data, anytime they're correcting data, any kind of information that would be useful when you are doing analysis. 4 is a data set search bar. As you can see, I've typed in STEM because that's what Peers is about, is STEM education. So from there, it's a typical search bar. You type in a keyword, click on it, and see what comes up. 5, it'll come up with a list of data sets that contain information about STEM. This one, the first one that came up was high school and beyond. There's usually, you see a negative sign here, but it's a plus sign. When you click on it as a plus sign, it will drop down and give you information about this particular data set. It will tell you a description of it, what population it contains, a code book by subject matter and variable names. It'll give you some keywords, and it will also tell you the type of analysis that can be conducted on this data set through the data lab tool. And 6 is the launch button. Basically, what it boils down to in this system, there's 3 basic steps that you're really looking at here. A lot of this is exploration. I'm trying to give you some simple examples to get you started on your way, but there's a lot of nuances here. I encourage you to explore them. I encourage you to learn more about it. But in general, the way to get started is we select the type of analysis we want to do. The analysis is a selection, a pull-down menu of basic descriptives, percentiles, averages, mediums. It also does linear regression, logistic regression, and correlation matrices. Here in this area, this is all the variables, and they group them by theme. So when you click on any one of these, you will see specific variables in a pull down menu from there. And they also give you a symbol which tells you whether that variable is continuous in nature or categorical in nature. So you've chosen your analysis. It's here where you choose your variables. And then finally, you run the analysis. Very three basic steps that are happening. But I'm going to take you through a specific example, steps that you can look at. First thing here is we have this button here, students, and from there you can choose different types of students for whatever you're interested in. I chose post-secondary students. Where it says STEM here, that's usually says all topics, and it's a pull down menu again, and I chose STEM, or I could also have typed it into the search bar. For this case, I chose the baccalaureate and beyond data set, which again gives me basic information of what's in this data set, who's in this data set, and what kind of analysis that I can do. And then we launch to the next step in this process. So you can also see that over here, we have this little white kind of button area. When you have completed an analysis and generated output, it will show you a code. That code you need to write down, keep it, because if you want to go back to that analysis, you can go directly put the code in here and say go, and it will take you directly back to your generated output. And so keep track of those codes. Here's a specific example of using the Power Stats process. I chose the type of analysis. I chose the basic analysis percentage distribution. Secondly, in this area here, I chose a variable. Again, I went down here and I think I looked for demographics, characteristics, clicked on here, and I chose sex assigned at birth. I literally took this and dragged it over here to be my column variable. I wanted to create a cross tabulation table. So I chose education majors. And I came over here and I dragged it over here. And then from there, I also filtered into the kind of majors that I was interested in, which were STEM majors. Here it shows you a preview of the structure of what your generated output will look like. And there's the run button is up here. So once this is the generated output that you would receive for a cross tabulation table of gender assignment and STEM majors. Up here, you have actually a choice. It's another pull down menu, and you can either choose estimates only, estimates with standard errors, or estimates with confidence intervals. So you have some flexibility of what you want to look at. I just wanted to give you the basics here. I think it's sort of interesting to note that overall in this particular database, we have 57% females and 42% males, 43% males. However, if you look of those people who have computer science degrees, out of computer science and information sciences, 85%, 86% are males and 14% are females. But if you look down in biology, you got 57% women or females and 43% males. Some interesting statistics. What I think is important to understand about these kind of tables and generating this kind of information, this gives you some basis of what's out there. Like, it was very surprising to me you still had a lot of males in computer science, but in biological sciences, females are a higher percentage. That kind of information helps you build on the kinds of ideas and research that you want to do. You may not want to just dive into a whole data set, but you just may want to get parameters and understand what is going on out there. Also down here is what I talked about. The code to retrieve results is, and they gave a code NOSMAW. This is the one that I was talking about. If you wanted to go back and retrieve this output, that's the code you would put in, and it would take you directly back here. In addition to having these online data tools at NCES, you can download data directly. If you want to get into the, I would say the weeds, if you want to have more power to manipulate the raw data, this is where you would look. This, interestingly enough, if you're going to look for a keyword for downloadable data, it's actually called online codebook. Sort of interesting to me, but that's what gets you to the downloadable data. It has a drop-down menu, all levels of education, and you can choose all levels of education, and you can use subgroups of education. You can choose, this drops down all the studies that you can select from. And then also over here's a launch button. And here what we see is when there's studies that have more than one cohort or more than one panel or more than one wave to it, it will have a drop down and show you all the years or panels or waves that are available to you, and you can decide which one that you would like to look at. So this slide here, I just put this in because this is their actual formal instructions on how to use the online code book, and I thought it would be nice to have it in there for easy access. But you can find this on their website. Well, what I did is I chose to look at the National Education Longitudinal Study of 1988, NAILS. I chose to look at the particular wave that says base year to fourth follow-up. I looked at the particular file called student pub. The variable type that I was really interested in was race. And you can see we have 4 different variables for race. And in addition to that, I just clicked on several different variables to have a little bit of a small data set to download. What's also interesting that you can ask through, you go to your profile and you can do there's a checkbox asking for including automatic variables. And these automatic variables include sampling variables, ID variables, questionnaire variables, weight variables. And, these are some of the selected variables that we need when we're doing analysis, particularly when we don't have a simple random sample, and it's more complex than that. So this box gets generated and it tells me some information. It tells me I have a total of 39 variables, 29 I selected, 10 are automatically included. Those are the weight variables, et cetera, and so forth. You can add to click more variables, and you can include as many as you want. I do not know if there's a limitation on the size of the downloadable file. I didn't test that out, but there may be. So you may want to ask about that or find information about that. But what also this gives you, it gives you enough information when you do get the downloadable file, you can check against this and say, oh, I'm supposed to have 39 variables. How come I only have 16? Something went wrong. So it's metadata that helps us know if we've got a correct download or not. Once you want to download, you hit the download button here, and this box will pop up. Download. It gave you a lot of options of how you want your download to be. Now, I chose select file. I wanted my data files that include my data set, my code book, and my record outlay or my record file layout. But I also wanted the syntax file. So I wanted both. I am a long-term SAS user, and so I'm comfortable with that particular piece of software. But if you're not, you are given the options of SPSS or Stata or S plus or R, or you can do ASCII or a CVS file even. So whatever you're more comfortable with, you have many options that will be produced for you. Once I've decided on SAS, this pops up, get SAS formatted data files. I click here, and then you will see down in this area, it will give me the linkages of the various files I need from SAS. The data sets themselves, the code books and record layout files, and the formatted syntax files. Now, for some people, they might not want the syntax file. I particularly like to have the syntax file because I like to see how the data was generated, if I understand how it was generated, and also it may serve as a code that I could modify in the future when I'm working with the files. So when you click on each one of these, you will get a zip file that is downloaded into your downloads folder. And then you click on the zip file and you can see the relevant files that you need to work with. So there's two ways at NCES that you can get public use data. One is using their online analysis tools, and the second way is actually downloading the data itself. Again, they have different purposes, and you need to find one that fits what you're doing or work with both of them jointly to get to the mission that you've set for yourself. I want to talk about our second statistical agency, the National Center for Science and Engineering Sciences. And it's under the umbrella of the National Science Foundation. It has, I've listed here the most used or popular files that people focus on when they go to this website. There's an asterisk there. Most of these files, all these files are not found at the ICPS archive. And the one that is found is the National Survey of College Graduates, and we have an earlier version of that. And these are the URLs that you can go to directly to get to their websites. The National Center for Science and Engineering Statistics makes it super easy to download a data set. You can go and click and you will find that they have a list of all the public use files that you can download. In this case, the National Survey of College Graduates has numerous years associated with it. I took the most current one they have. You basically click on the download link here, and it will download a zip file into your downloads folder. Couldn't be any more simpler than that. Once you get that zip file, open it up, and I think the most important file you'll find there is the readme.txt file, because that gives you all this information that tells you, it's a map that tells you, what else do I have in this file here? What else do I have in this folder? Let me point to the ASCII. It gives you both ASCII and I asked for SAS data sets. So right here, we find that, the name, and it's in SAS for a Windows format. The next thing that's important to me is the data dictionary. And that, from a SAS programming viewpoint, it gives you the SAS data name, and it gives you the metadata about that, the length of the variable, the kind of variable, the basics, basically. Down here, we find codebook information, and they give you the codebook information in two ways, an HTML file and also a PDF file. Code books are the GPS of research. So open them up, get familiar with them. I think it saves people a lot of time and energy and effort when they do that. And what is really nice is it actually gives you information about the person at this agency that is responsible for this particular data set. And it gives their email. And so you actually have somebody you can contact if you have a question. In this day and age, that's really a treasure. So I really appreciate that. Now, the National Center for Science and Engineering Statistics also has their own online data tools. There are 4, the Data Explorer, the Chart Builder, the Table Builder, and their own version of Power Stats, our data lab at NCES. In all honesty, investigating and looking at each one of these would take a lot of deep dive and time. So I found a video that a webinar they produced a couple years back, which I thought was very, very useful. And they go through the Data Explorer, the Chart Builder, and the Table Builder tools, as well as I think the statistics system. But I thought for this webinar, we would focus on the statistical online tool that they have. But if you want to know about the others, visit this webinar. So this is a demonstration of their online data analysis tool, which can be found at this URL. Once it pops up, you want to look at the data tab. And if you want to generate your own data tables, you click right here on this CSTAT data tool. The next thing, it's very sequential. You want to select the survey. So this is the surveys that are available for this data tool. I chose the National Survey of College Graduates 2021. The next step is to choose the variables. I find in both these online data tools, you have lots and lots of variables. So you have to have a little bit of patience of what you want to choose. Again, the code book is very useful because they are in whatever programming language. It seems to be SAS here. Variable names. I wanted to keep this example simple. I just wanted to show you the structure of what's happening here. So I chose a variable, which is the field of study for the highest degree that you've gotten. As you can see, it's quite a long variable name with a lot of special characters in it, et cetera, and so forth. But that's the one I chose. And let's go to the next step. The next step is specifying the response categories of this variable specifically. So this variable actually had 7 response categories for it. You can create conditional statements. The variable equals, and I wanted to look at all 7 categories. So I went through the first category. It's a point and click. Once you have the statement, you hit this down arrow. It places the statement in this conditions box. Then you go to the next one and you keep doing that. Now, this or here is a toggle switch. It's when you first do it, it says and, but you can toggle it to or. Obviously, in this particular case, an and statement would probably yield no results because nobody's going to have 7 different highest degrees. So it had to be an or statement in this particular situation. So the next thing is you're asked what kind of analysis you want to do. Because it's a categorical variable, all I look for is the count. So once we go to the next step, generate the table. We have our variable, we have our conditions, we have our data type, number of people. I wanted weighted data, so that is checked, and I hit the submit button. And this generates the table. As you can see, it's just weighted totals for each of the fields here. This generated table can be viewed in Excel, and if you go up here, view the results in an Excel spreadsheet, and it will download into your download folder an Excel spreadsheet for you to look at. Now, I just want to do a little modification of this request. If we go back and we look at this screen here, there are some options up here. I chose, show me the percentages also. I still wanted it weighted. I submitted it again. And this time, as you can see in the output, not only do I get the weighted totals, but I actually get the percentages for the row too. Like I've said before, a lot of this is you exploring. There's lots of options there available for you. At NCES, there's options to do linear regression, logistic regression. So it's a matter of just getting in there and exploring things and becoming comfortable with them. If this is the type of analysis you want to generate and use. So after we've gone through the National Center for Educational Statistics and the National Center for Science and Engineering Statistics, I also wanted to bring it back home to the ICPSR. ICPSR is a data archival organization that's been in existence for 62 years. We presently have over 20,000 different studies, over 6 million variables, and over 115,000 publications have been derived from those studies. It's a wealth of information and data, ranging in topics from education, health, social science, voting behavior, the arts. I was told there's data that goes back to the 1200s about executions in France for a year. So you're looking at something that is all housed in one place for you. Now, the consortium is a consortium of membership. What you might want to ask yourself is my institution, whether it is an academic institution, whether it is a research institution, a statistical research institution, you want to look to see if your institution is a member. It does cost for membership, but there are benefits of membership. If you are a member of one of these institutions, whether you're faculty, staff, student, you have access to many of the benefits that are offered at ICPSR. So if you want further information about ICPSR and membership, please follow this URL and it will give you a lot of information. We are not only housing data, but we have programs that teach cutting edge analytical techniques through our summer program. We have webinars, we have all kinds of things that are going on here within the social science research arena. At this time, are there anybody that has questions?
Catherine, I see one question that has come in. Can you explain the difference between weighted and unweighted?
Yes. When you're doing a simple random sample, that's the old-fashioned kind of like picking something out of a jar randomly, and you're only wanting to talk about that population that you are looking at, we don't have to weight that data. We don't have to explain that it has capability to make inferences to a overall or general population. But most of the time, we just don't want to describe a particular set of people. So we want to have the capability to generalize that beyond that set of people. I mean, right now we are in the middle of this country. Always you hear poll this, poll that. Uh, they're taking a sample of people and they're projecting from that sample what the probability is for different political outcomes. A lot of times, data it's very expensive to collect data. So we don't have the capability to survey the 300 million people in this country. I worked on a project many, many years ago that looking at Hispanics, uh, Mexican Americans, Puerto Ricans, and Cuban Americans, and getting a profile of health measures for them. First time it was done in this country. Well, we couldn't go around and survey every single Latino in those groups. So they took a sample in various places to represent all Mexican Americans or all Cuban Americans or all Puerto Ricans. But they wanted to make sure that it regionally that they were capturing different parts of this country. So when they would go to places like, I don't know, Bluefield, West Virginia, you're not going to find it doesn't have a large Latino population. So when they would survey that a person, maybe they surveyed a 10-year-old Mexican American boy, they weighted him, they gave him more importance to represent all 10-year-old Mexican American boys. And that's where the weight comes in. It expands our power to make inferences. And that's the difference between unweighted and weighted.
Great. Another question we've had come in is it possible to get data on school districts from these data sources? This person would like to compare school district information and they're having trouble finding district level data on percent of students in different programs.
I believe there is. I can't tell you directly what that data set is, but I know that at the National Center for Education Statistics, I think they do have data that is at the district level, even maybe at the school level, but I can't tell you offhand what that is. If you would like to email me, I can, investigate that a little bit further for you. But yes, I think it is possible.
Great. We have another question that came in. First, they said, thank you for this wealth of data resources. Sometimes reviewers seem to be critical of data sets that are older. For example, early childhood longitudinal data. How do you suggest responding to such criticisms?
I think that is a common thing that people are they don't want to look at older data. Um, I think older data can be rich data. I believe that right now, the program director for peers is working, and I think we have a webinar that may be coming up, but they've taken older data and now people want to revisit that because they surveyed those people, 20 years ago, and now they want to go back and see how things have changed for them. So they have this panel of people, so then they can compare. They can compare maybe what they thought they were going to do as an occupation and they turned out to have as an occupation. Uh, You can look at trends in older data and look at trends now. The shame of it all is that collecting data is a very long-term, expensive process. And it's a sad thing is that we just throw it sort of out with the bathwater. I think there's richness, but I think, it takes a special kind of study or research question to address it. But I understand that's a very common criticism.
Um, is there a simple way to download a data set from the NCES in its entirety instead of having to choose individual variables and create an extract?
I have not tried it I did this as a simple exercise. I have not tried a full data set. Um, I think you could try and see what happens. My fear is that it's going to be very large and that it would exceed the capabilities of the technology. Um, as much as I hate to say this, downloading um, parts, not necessarily, maybe you can get all the variables, but you may not be able to download all the respondents, that you would have to do those in batches. And then the most important thing to put it back together again is you have a variable that is a common identifier. Merging data sets together, I think that is the key. You've got to have that ID in there. But I think I'm not quite sure if it would work or not, but I'd give it a shot and see. And if not, I think I would strategize by trying to download parts of it and making sure I had a connecting variable to merge the stuff back together again.
Okay, another question about NCES. Can you please briefly review the login info for the NCES website?
When you get to the website, there is at the top of the page a create an account. So you can click on that, and it's pretty much similar to every other kind of place we have to create accounts with. They do send you an email letter or instructions in an email. So whatever email that you want it to go to, and there's a link to set up your password. I have found though, I thought, okay, that's great. Now I'm on there, but every time you want to do analysis, it seems like you have to put in that email and that password. So be aware that, it doesn't just stay around, but they'll ask you to log in. Sometimes it seems like more than once when you're in a session, or not particularly in a session, but you think, okay, I'm still logged in. But when you start something new, they may ask you to log in again.
Okay, those were all the questions that we had come in at this time.
Well, I think if we've reached the end of our time together, so I'd like to thank all of you for joining us. And I really appreciate you coming in and learning about the possibility of exploring data and secondary data particularly. Um, the recording of today's webinar will be available in the Data Fair playlist within approximately 48 hours. We invite you to visit the URL log link that for the Data Fair to find the link to the playlist and to register for the remainder of any ICPSR Data Fair webinars. Thank you all again for being here. Thank you for going on this journey with me in navigating these waters, and I hope you enjoy the rest of your day.